Today we'll be learning how to solve exponential equations using logarithms. The first problem asks us to solve for x in the equation 10 to the power of 5x equals 40. This equation is currently in the exponential form. Therefore, we must first convert it into logarithmic form in order to solve for the exponent where the variable x is located. Logarithms are the inverses of exponentials, so we can use one formula to solve for the other. To do so, identify which values are a, b, and c. In this case, our a value is 10, our b value is 5x, and our c value is 40. After substituting a, b, and c into our conversion equation, we get the same problem in logarithmic form. Log base 10 of 40 equals 5x. Next, we isolate the variable x by dividing 5 from both sides to get the final answer in terms of base 10 logarithm. However, we must input the expression into a calculator to get the final numerical answer of 0.32. The second problem requires us to solve for t in the equation 10 to the power of 0.2t equals 64. Like the first example, the equation is in exponential form, so we must convert it. The same conversion rules apply, but in this case, a equals 10, b equals 0.2t, and c equals 64. Then, substitute the values in the conversion to obtain the logarithmic form of log base 10 of 64 equals 0.2t. Note that log base 10 can also be written as just log. Then, isolate the variable t by dividing both sides of the equation by 0.2 to get the final exact answer in terms of base 10 logarithm of t equals to log base 10 of 64 equals 0.2. Input the expression into a calculator to get the approximated numerical answer of 9.031. The final problem asks us to solve for y in the equation 2 times 10 to the power of 3y equals 26. For this example, conversion into logarithmic form is needed, but before we can do that, we must isolate the 10 to the power of 3y by dividing both sides of the equation by 2. This results in the equation 10 to the power of 3y equals 13. Once again, we identify the a, b, and c values as 10, 3y, and 13, and convert the equation from exponential to logarithmic form of log base 10 of 13 equals 3y. Finally, solve for the unknown variable y by dividing both sides of the equation by 3 and getting the final answer of log base 10 of 13 over 3 equals y in terms of base 10 logarithm. A calculator is then needed to find the estimated numerical answer of 0.371. And that concludes my presentation on how to solve exponential equations using base 10 logarithms.